Hello, in this video I will do an SAT practice exercise on right triangles and trigonometry, and these are technically easy ones. Um, so if you don't know about trig, it might not be too easy, but if you do have a little bit of background in trig, this is fairly simple. So let's look at question one. In question one, in the right triangle XYZ, where y is the right angle, cosine of z is positive 4/5. If the side lengths of the triangles are whole number values, what could be a possible length in units of side YZ? So if you look at your triangle, draw your triangle, right? And they specifically said that Y is the right angle, so you could put Y here. And then this is going to be X, and this could be Z, right? They want to know what is the possible length of YZ. So they want to know this length. Now, I know what you're thinking. So if you did the SOHCAHTOA, right? They give you one piece of information. Cosine of Z is positive 4/5. Cosine is the adjacent over the hypotenuse. Okay. So yeah, look here. So if you look at angle Z, adjacent is 4 and then 5. But isn't that our answer? They're saying what is the length of YZ? Isn't YZ this length, which we just said was 4, which was given? Yes, it is true, but they're saying what could be a possible length. They don't want to, that's the key word, what could be a possible length. So do not try to find this side length. And by the way, this would be a 3, 4, 5 triangle. And then assume that this is your answer. No, they specifically want this length, and it's 4. So what could be a double? So it's not 3. Could it be 6? I don't think so. If you double this triangle, if you made this triangle slightly larger, right? If you double this, this would be this length will no longer be 4, it would be 8 if you double that. This length here would be 10. So yeah, this would be 8. So yeah, right. 4/5 is the same thing as 8/10, right? Cosine is adjacent over hypotenuse, so 8/10. 8 can be reduced by 2, so that would be 8 divided by 2 is 4. 10 divided by 2 is 5. Definitely true. So your answer will be 8. Okay, next question. Question 2. Am I clear? So question 2 says a 15-foot ladder is leaning against a building. If the angle of the ladder makes when if the angle of the ladder makes with the ground is 60 degrees, what is the distance between the ground and where the ladder touches the building in feet? So you kind of need to draw uh, an image, and it has to be exact image. So here we have a right triangle, or here we have a ladder that's 15 feet, and it somehow forms a right triangle like this. And they're saying that if the angle the ladder makes with the ground is 60 degrees, so this angle here is 60 degrees, what is the distance between the ground and where the ladder touches the ground? So this is the building. What do they want? Do they want this distance or this distance? They're saying, what is the distance between the ground? Here's the ground and where the ladder touches the building. So I think they want this distance. Okay. So yeah, that is kind of, yeah, that's kind of difficult. Uh, So how do we find this leg or this length? So because it specifically is a right triangle, you can use SOHCAHTOA. Okay. And what could we do is if we want to find this unknown length or this leg, and we have a hypotenuse is 15 and we have this angle, what should we use? Should we use sine, cosine, or tangent? Yes, I think we should do cosine because cosine of 60 degrees is adjacent over hypotenuse. So here's angle 60. No, not cosine. That won't work because we want to find this length. Adjacent would be this length, which is we don't need to know. So I think what we're going to do is do sine because sine 60 degrees is opposite of our hypotenuse. So opposite is x and then the hypotenuse 15. Okay, go ahead and cross multiply. So what's 1 times x? X. And then it's 15 times sine of 60. Okay. Then what we're going to do next is find. So in the newer digital SAT, you can use a calculator. So if you do put it in the calculator, 15 times sine of 60 is, what is it? It's about 12.99. So I think, yeah, in newer digital SAT, you can use a calculator. I think you have Desmos. So if you put that in Desmo, it is 12.99. So what if you uh don't have a calculator, or what if you want to know if like from scratch? So with from knowing it without a calculator, this is how you can figure it out. So this is 60, and then this, I know this is going to have to be a 30. So we're dealing with 30, 60, 90 right triangle. So what does a 30, 60, 90 right triangle looks like? It looks something like this. So here's 60, here's 30. So according to the rule, the angle 30, so here's angle 30, it has a side length. So if you bring an arrow down here, it would be this length has a length of x. And then the angle 60 has a side length of x radical 3. And then your hypotenuse is 2x. Do we have any of these information? Yes, we have the hypotenuse. Our hypotenuse is 15. So we could say 15 is set equal to 2x. And then you're going to solve for x by dividing both sides by 2. And then 15 over 2 is 7.5. Okay. So what that means is this length here, or sine of 60. So sine of 60, right? So this part here, sine of 60 is wait, so we found our x, which is 7.5. So this length here is x times radical 3. So that would be 7.5 radical 3. And then this length here is x, which we said was 7.5. And then 7.5 times 2 is 15. So sine of, because we need, it's 15 times sine of 60. So sine of 60 is opposite of our hypotenuse. So opposite, which is 7.5 radical 3. And then hypotenuse is 15. So really, without a calculator, it's 15 times sine of 60. So it's 15 times 7.5 radical 3 over 15. And then what happens is the 15 cancels. So you're left with 7.5 radical 3, which is this answer. But if with a calculator, it's about 12.9. So this is how you do it without a calculator. This is how you do it with a calculator. Okay, so 7.5C. Okay, let's move on to question three. Question three says a right triangle has a hypotenuse measuring 26 inches and a leg measuring 24 inches. What is the measure in inches of the other leg of the triangle? This one's really not too bad. So just draw some kind of right triangle, right? And just make sure okay, so one of the our measurement is a hypotenuse, which is 26. And then one of the leg is 24. So you could put 24 here or you could put it here. It doesn't matter. It really doesn't because what we're going to use now is to find this other leg is Pythagorean theorem because it is a right triangle. So Pythagorean theorem is a squared plus b squared equals c squared, right? So one of my leg is 24. My other leg is unknown. We'll call it x. And then my hypotenuse is 26. Okay. So what is 24 squared? It is 576 plus x squared. And then 26 squared is 676. Okay, subtract 576 from both sides. So it's x squared equals to 676 minus 576 is 100. Take the square root of both sides, and you get x equals 10. Okay, so that's how you do question three. That wasn't too bad, right? Let's move on to question four. In question four, in the right triangle ABC, where B is a right angle, sine of A is positive 3/5. What is the value of cosine of A? So go ahead and draw a right triangle. Uh, in a right triangle ABC, where B is a right triangle, so A, B, C, and then draw your little box image. And then they're saying that sine of A is 3/5. So we'll definitely have to use a SOHCAHTOA. So sine of A is opposite over hypotenuse. So first locate where angle A is, and ours is, we have 3/5. So what that means, 3 is the opposite and 5 is the hypotenuse. So locate where angle A is, and then determine where the opposite side. So the opposite side is this side. So this length here, or BC, is 3, and then the hypotenuse is 5. What is the value of cosine of A? So cosine of A is adjacent over hypotenuse, so it's going to be this length over the hypotenuse. So what is this length here? That is a right triangle. That is a leg, and I know it's a special one. It's a 3, 4, 5, but if you didn't know that, you could just do the Pythagorean theorem, right? 3 square plus x square equals 5 square. So 3 square is 9 plus x square, and then 5 square 25. Subtract 9 from both sides. 25 minus 9 is 16. Take the square root of both sides. X equals 4. Okay. So what is the cosine of A? Cosine of A is adjacent over hypotenuse. So from this angle A, my adjacent side, which we just found, was 4. And then my hypotenuse is 5. That's it. Okay, move on to question 5. In question 5, in a right triangle, tan of theta is 24/7. What is the possible length for the hypotenuse of the triangle? So in a right triangle, So tan of theta is 24/7 was the possible length. So they don't give us any angles, so we know that it's SOHCAHTOA. And what else do we know? Tan is, so where are we gonna, you can locate theta anywhere. You can put it here or here. It doesn't really matter. It won't be wrong. So if I put theta here, and so my tan theta is 24/7. So tan is opposite over adjacent. So here's theta, the opposite side. So this 24 represents the opposite side. This 7 represents the adjacent side. Okay. So tan theta, so 24 opposite is here, and then adjacent is here. What is the possible length of the hypotenuse? So we got to find this length. So to find the hypotenuse, what is the possible length for the hypotenuse? So all you got to do is do the Pythagorean theorem, right? A squared plus b squared equals c squared. So one of my leg is 7. One of my other leg is 24 equals c squared, right? So 7 squared is 49. 24 squared is 576 equals c squared. And then 49 plus 576 is 625 equals c squared. And then take the square root of both sides. You get square root of 625 is 25. Okay, so my hypotenuse is 25. Okay, let's end and score. I think we got everything right. Let me double check. So this is January 1st. Yep, we got everything right. So there's one more. Yeah, there's another part of this for the easy one. So let's continue with that one. Okay. Okay. So let's do this part. So this is continuing on right triangles in trigonometry. So question one says in triangle ABC, angle C is a right triangle. If sine of A is 2/3, what is the value of cosine of B? Uh, Okay, so let me just do this one. So in triangle ABC, triangle ABC, C is a right triangle. So here's C. Triangle ABC. If sine of A is 2/3, so Katoa thing. So if sine of A is 2/3, so sine is opposite over hypotenuse. Okay, so here's sine of A. Opposite is this side, so this is 2, and the hypotenuse is 3. And I think we should find out this length because if we want to find cosine of B, which is at this angle, It's adjacent. Oh, we don't actually. Cosine of B, here's angle B, is adjacent, just 2, and then hypotenuse is 3. So it's actually 2/3. Okay. Okay, let's move on to question 2. A cable goes from the ground to the top of a building. If the angle cable makes with the ground 53.112 and the cable is 15 feet long, approximately how tall is the building? So yeah, so it's just a simple right triangle like this. Here's the building. The angle is this is the cable is 15, so this is the cable, which is 15. And yeah, and they're saying that if the angle the cable makes with the ground is approximately 53.112, so here's the ground. I believe this is your angle, 53.112. Uh, how tall is the building? So yeah, here's the building. How tall is it? So we're definitely going to use SOHCAHTOA. And I think we do have to use a calculator for this one. So we gotta find this line. So what should we use? Should we use sine, cosine, or tangent? Let's see. We have an angle. We have a hypotenuse, which is 15. We have to find this unknown leg. So I think we're going to do sine because I'll show you. Sine of 53.112 is equal to opposite over hypotenuse. So opposite is x, and then the hypotenuse is 15. Cross multiply, so 1 times x is x equals 15 times sin of 53.112. And that gives you, so with the calculator, 15 times sine of 53.112 is 11.99. So our closest answer will be rounded to 12. Not too bad, right? Let's do this one, question 3. Note figure not drawn to scale. Triangle EFG shown above is a right triangle. What is the length of FG? This is really simple, right? Um, they give you a leg, which is 9, and they give you a hypotenuse, which is 15. We got to find another leg, so we got to do Pythagorean theorem, a squared plus b squared equals c squared. So one of my leg is unknown, I'll call it x, so I'm going to square that. One of my other leg is 9, so that's 9 squared. And then my hypotenuse is 15 squared. So it's x squared plus 9 squared is 81. And then 15 squared is 225. Subtract 81 from both sides. So you get x squared equals to 225 minus 81, which is 144. Okay, take the square root of both sides. X equals 12. Okay, let's move on to 4. Note figure not drawn to scale. Triangle JKL above is a right triangle, and sin of J is x over 20. What is the value of x? Okay, so first we're going to definitely do SOHCAHTOA. And here, locate where angle J is. So angle J is right here. So sine of J is opposite over hypotenuse. So locate angle J is right here. So the opposite side is 16, and then the hypotenuse is 20. They want to know what this x is, which is the opposite side, which is 16. Okay. Not too, yeah, not too bad. Oh, yeah, I did. Okay, question 5. So the value of cosine theta is 1/2. If the value of theta in radians of k pi and k is between 1 and 0, what is the value of k? So cosine theta is 1/2. Oh yeah, I remember this one. Okay. So where in your unit circle, so where in your unit circle gives you a cosine of positive 1/2? So if you draw your kind of like your unit circle, I think that's only could be related to quadrant one. So for example, 30 degrees has an x coordinate or a cosine of radical 3 over 2, comma 1/2, right? 45 degrees has an x coordinate of radical 2 over 2, comma radical 2 over 2. And then the 60 has an x coordinate of 1/2 and a y coordinate of radical 3 over 2, right? So how I know is it's always flipped. So what is the value of k? So cosine theta of 1 + 1/2 is related to 60 degrees. Or in radians, what would that be? How, what is 60 degrees in radians? 60 degrees in radians. So if you forget, just multiply this by pi over 180, and you get 60 pi over 180, and this cancels, so you're left with 6 pi over 18, which you can reduce by 6. So that would be pi over 18 divided by 6 is 3. So you get pi over 3. So k has to be less than 1 but greater than 0. If the value of theta in radians is k times pi, if the value of theta. Oh, okay. So yes. Okay. So theta, they're saying that just replace theta with k times pi. So okay, so somehow we have to get pi over 3. So all you got to do is set k pi equals to pi over 3. And then you'll solve for k. So get rid of this pi by dividing both sides by pi or multiplying by 1 over pi. So the pi's cancel, so you're left with k equals 1/3. That's true, right? 1/3 is technically less than 1 and greater than 0, so that's how you get 1/3. So yeah, this is SAT practices on right triangles in trigonometry, and these were technically fairly easy ones. Okay, I am going to stop here.